Welcome back, everybody. In this video, we will be covering the third part of Lecture 11. The topic is the binomial option pricing model. Prior to the break, we set up the binomial model on the tree, and we also priced European call options on the binomial tree using no arbitrage/replication techniques. We will now use the binomial model to price European put options. The idea will be very similar to that of the call option, except the formula will change by just a little bit. Okay, let's get started. So consider a European put option on our non-dividend paying stock S. The strike of the put option is given by K, and the maturity of the put option is date or year T. Our goal is to calculate the price, P0, of this European put option, and we will do so using the binomial pricing model again. Okay. Let's start by adding the put option to our binomial model. Originally, we had just two assets, the stock and the bond. The stock had a price of S0 today, and the stock's payoff depended on the state of the world at date capital T. In the upstate, the stock's payoff was S sub U. Okay, this was given by the gross rate of return U times today's price S0. In the downstate, the stock's payoff was S sub D. This was given by the gross rate of return in the downstate, D, times the stock price today. The bond's payoff, BU and BD, was 1 in every state, and this was because it was risk-free. And the price of the bond today is just the discount factor, e to the negative RT. We now introduce a third asset to the model, which is the put option. The put option has an unknown price today. This is what we want to calculate. And the payoff to the put depends on the payoff of the stock at the later date. It's a derivative with the underlying equal to the stock. In the upstate, the put's payoff is P sub U. This is equal to the maximum of K minus S sub U in 0. In the downstate, the payoff to the put is P sub D. Again, this depends on the stock's payoff at the later date. It's just the strike K minus the stock's payoff, S sub D, and 0, take the maximum of those two. To solve for the option price, P sub 0, which is what we want, we're going to use pricing by replication again. Recall that pricing by replication proceeds in two steps. First, we find a portfolio whose payoff at date T replicates the put option. So we want a portfolio YT whose payoff equals the put option. Okay, and then the law of one price is going to tell us, okay, that if these two payoffs are the same at date T, then their prices must be equal at date 0. Okay, so consider forming the following portfolio at date 0. You're going to own delta shares of the stock, or we're going to solve for delta in a second. And you're also going to own beta risk-free bonds, each with a face value of 1 and a price of e to the negative RT. We'll call this portfolio as portfolio Y again, like we did with the call. Okay. The payoff to portfolio Y is as follows. In the upstate, we're going to own delta shares and beta bonds. Each share is going to be worth S sub U. Each bond is going to be worth 1. We own delta of these shares. We own beta of these bonds. So the total payoff to this portfolio is Y sub U in the upstate, delta times U times S0 plus beta times 1. In the downstate, we still own delta shares and beta bonds. This time the stock price is going to be different. It's going to be S sub D in the payoff. Okay, and the bond price is going to stay the same as Y. Okay, thus the payoff to the portfolio in the downstate, Y sub D, is equal to the number of shares we own times the price of the shares, delta times S sub D, plus the number of bonds we own, beta, times number 1, which is the face value. Okay, so Y sub U and Y sub D describe the payoff to the portfolio Y. Okay, and so if we want to find the put price based on Y, what we need to do is we need to choose these delta shares and these beta bonds such that Y is exactly the same as the put option in every state of the world at date T. Okay, to find the put price, that is, we need to set the payoff on the portfolio equal to the payoff of the put. And the way we do this is by choosing the number of shares delta to hold and the number of bonds beta to hold as well. Okay, once this is done, then we can come back up here and use the law of one price. Okay, this table or this graph visualizes what we just talked about. Again, the situation's as follows. There's three assets. There's the bond, okay, there's the stock, and there's the put option. Okay, the stock has a random payoff at the later date. It's either SU or SD. The bond has a constant payoff in each state. It's always equal to 1. Okay, the put option's price is what we want to calculate. It's P sub 0 right down here. It's what we want to calculate. Okay, to do this, to price this put option, we're going to form the portfolio Y. Y is equal to delta shares and beta bonds. All right, we're going to try and choose these delta shares and beta bonds so that the payoff matches the payoff of the put in the up and the down state. Okay, the payoff of the portfolio in the up state given a delta and beta is just delta, the number of shares we own, times the price per share, plus beta bonds we own times the face value of 1. Payoff of the portfolio in the down state is the number of shares we own delta times S sub D, plus the number of bonds we own beta times 1. We want to choose delta and beta such that P sub D and Y sub D are equal, and P sub U and Y sub U are equal as well. Once we have this, we can then price the portfolio using the law of one price. We know what the price, so we know this. We know the price of the portfolio today. It's equal to Y0, okay? And that'll allow us to solve for the put price. Okay. So now what we're going to do is we're going to solve for the optimal delta and beta that mimics the payoff to the put option. Okay. To do this, we're going to set up a system of two linear equations. In the first linear equation, we're going to match the payoffs in the up state. So this first one is for state U. And in the second linear equation, we're going to match the payoffs in the down state, state D. In the up state, the payoff to the put, PU, must be equal to the payoff of the replicating portfolio, okay, YU. The payoff to the replicating portfolio again is delta times SU plus beta times 1. Okay. In the second equation, okay, we need to set the payoffs equal in the down state. That is, the payoff to the put, P sub D, must be equal to the payoff to the portfolio, delta times S sub D plus beta times 1. The latter is just equal to Y sub D. Okay. These two linear equations describe the system that we want. Okay. This is a system of two linear equations and two unknowns. The unknowns are equal to delta and beta. Okay. If there is no arbitrage, like we showed in the last lecture, then this system is going to have a unique solution. The solution is going to be given to you in the slide in the bottom portion. The delta that equates the payoff on the replicating portfolio to the put is going to be equal to P sub U minus P sub D over S sub 0 times U minus D. Notice that that bottom portion is just S sub U minus S sub D. Okay, and notice also that this delta is going to be less than or equal to 0 in most cases. Okay, and usually if we arrange this correctly, we're going to have that PU is less than PD. Okay, in the second case, what do we have? This is beta describes the number of bonds we need to own in the replicating portfolio. The equation that's going to equate the replicating portfolio to the put payoff is given to you. It's equal to P sub D, the payoff to the put in the down state, multiplied by U, the gross rate of return, subtracted P sub U, the payoff to the put in the down state, times D, the gross rate of return in the down state, all over U minus D. Okay? In most cases, this is going to be greater than or equal to 0. The replicating portfolio for the put is usually going to short the stock and long the bond. Okay? In other words, a portfolio of delta shares and beta bonds replicates the put option. Delta and beta are given by the below equations. We can just take these and memorize these if we want, but it's more useful, in my opinion, if we remember how we arrived at this solution in the first place. The way you do so is you just stack the equations that are given to you, the system that you want to solve. So say we have the system above. We note the state U equation as maybe equation 1. We denote the state D equation as maybe equation 2. We can solve for delta and beta using our 6th grade algebra again. Okay, if we subtract equation 2 minus equation 1, subtracting equation 2 from equation 1, what are we going to get? We're going to get that PU minus PD equals delta times S sub 0 over U minus D plus 0. This is going to imply that delta is equal to PU minus PD over S sub 0 U minus D. That's how we solve for the delta. It's an easy way to remember it, just to solve the system of equations rather than going on memorizing this long formula. How do we get the beta then? Well, we plug this delta in. Okay, we plug delta in to either equation 1 or 2. Okay, let's go with, say, equation 1. Okay, 1 plug in delta. Okay, if we plug in delta, it's going to become one equation and one unknown. That one equation is going to be PU equals to PU minus PD, S0, U minus D, times U times S0 plus beta times 1. We want to solve for beta, so we isolate it. Beta equals move everything to that left-hand side, cancel out like terms right here. Multiply that PU on the left-hand side also by U minus D, so the fractions are the same. So it's going to be U minus D, PU, minus PU dot U, okay, comes over here, plus PD dot U over U minus D, and then just combine like terms. This is going to equal PD dot U minus PU dot D over U minus D. Okay, so don't get me wrong, you can definitely go out and just memorize delta and beta, and so you know exactly what numbers to plug in once we get practice problems. But in my opinion, it's best to just write down the system of equations to begin with. It helps you learn, and you also don't have to do any memorization at all. You can just work through a 6th grade algebra problem on your own during, say, a test. Okay. So this portfolio of delta shares and beta bonds is going to replicate the payoff on the put option. We've chosen delta and beta such that it exactly accomplishes this goal. Okay, so this replicating portfolio replicates the put option's payoffs. And so the only thing left to do now is to apply the law of one price to figure out what the put price should be. The law of one price states that portfolios with the same payoffs, say if YT equals PT, right here, replicating portfolio equals the put payoff, then the law of one price implies that the prices at date 0 on these two portfolios or securities must be the same. Okay, so what we can do is we can just find the put price by plugging in our values. We know that Y0, given down here, for the put price is equal to owning delta shares, equal to owning delta shares and beta bonds. Okay. Well, what happens is that if you own delta shares and beta bonds, we want to know what the cost is or what the price is. Well, for each share delta, the cost of each share is S sub 0 at date 0. For each bond beta, the price of this is e to the negative RT. It's just a discount factor. And so the cost of owning the replicating portfolio Y0 is just delta times the price of the stock today plus beta times the price of the bond today. And if we plug in delta beta, so we plug in delta here, and we plug in beta, then what we're going to get is the put price. Okay, so the no arbitrage put price at date 0 is given by that final equation. It's equal to the put options delta, which is PU minus PD over S0 U minus D. This is the number of shares you own, multiply the price per share, S0, times the options beta. The beta is too messy. I'm not going to go on and read the whole thing, but it tells you the number of bonds to buy. And then you're going to just multiply this by the price per bond. Okay, the formula is messy, don't get me wrong, but once you know the underlying logic, go out, solve a system of two linear equations and two unknowns to find the replicating delta and beta. Then the price of that replicating portfolio is the price of the put. Price of the replicating portfolio is simple to calculate because you know exactly how many shares you own, which is delta. You know the price per share as 0, and you also know the number of bonds you own, beta, and the price per bond, e to the negative RT. Okay, easier to remember that way, the logic way, than just remembering the formula. Okay, very straightforward, very simple, just like pricing the call option, except we swapped C's for P's. So we'll do a couple of practice problems to reinforce our knowledge, and then we'll be done with this part of the lecture. So I'll give you a minute to read this question. I will then go out and solve the problem. Okay, so the problem statement is as follows. We're in a binomial world. There are two dates, 0 and 1. Both are in years. At date 1, there's two possible states of the world. The good state, upstate U, and D, the downstate or the bad state. Consider Red Rock Resorts from my hometown, Las Vegas. Okay. Price of Red Rock Resorts is $1 per share today. Red Rock Resorts does not pay dividends. At date 1, the price of Red Rock Resort can be one of two values. It's going to be a random variable. When the economy is good, it's going to be $2, S sub U equals 2. And in the down state, when the economy is bad, the price of Red Rock Resorts is going to be S sub D, which is 50 cents. The continuously compounded risk-free interest rate is 0%. Assume there is no arbitrage. So we're going to think about a European put option on Red Rock Resorts with a strike price of $1 that matures in 1 year. We want to answer 3 questions about this put option. First, what are its payoffs in the up and the down state? Second, what is the replicating portfolio for this put option? And third, what is the put option's no arbitrage price? So we'll start by writing down our inputs in the binomial tree. Okay, so we start by drawing it out. We have two dates, 0 and T. 0 is today, date T is the future. We have two states. At state 0, it's known today, so we know where we are. But in the future, there could be either one of two states. There's the up movement or the down movement. Okay. There are 3 assets in this question. There's a stock, a bond, and a call option. The stock is denoted by S0, its price today. This is equal to 1. The bond is denoted by B0. It has a price of e to the negative RT. In this question, the risk-free interest rate is 0%. Okay, we have 1 year, so the bond price is just 1. And the price of the call is our third asset. Price is unknown. This is what, whoops, excuse me, I'm sorry. Price of the put is the third asset. It's what we want to solve for, calculate. Now think about payoffs at date capital T. Our first asset is the stock. Payoff in the upstate is SU equal to 2. This implies that the gross rate of return on the stock in the upstate, U, is equal to S sub U over S0, or 200% gross return. In the downstate, the payoff is S sub D. It's equal to 1/2. Okay, this implies that the gross rate of return in the downstate, D, is equal to S sub D over S0, which is equal to 1/2 again. Okay, what about the bond? The bond in the upstate has a payoff of 1 and has the same payoff in the downstate. It's a risk-free bond. Its payoff does not depend on the state of the world. Okay, final part of this first problem is what we want to do is we want to calculate the puts payoffs in both these states. Okay, so we have two things. We have the puts payoff in part 1 of the problem. Okay, so the puts payoff in state U is going to be given as follows. Okay, it's going to be equal to the max of SU, the strike K minus SU in 0. Okay, the strike K in this problem is what? It's an at the money put option, so it's $1. If we plug in our inputs, the payoff to the put in the upstate is equal to the max of the strike, 1, minus the stock price in the upstate, 2, which the max of that in 0 is just 0. Okay, so the puts payoff in the upstate, we'll add it to our model, is just equal to 0. Now what about in the downstate? Put options are usually going to perform well in this downstate as long as we order the payoffs in a logical way. Put options payoff in the downstate is equal to the max of the strike minus the stock price in the downstate in 0. We know what K and SD are, so we just need to plug them into this formula. It's the max of the strike, 1, minus the stock price in the downstate, 1/2 and 0. This is equal to the max of 1/2 and 0, which is just 1/2. So we can add that to our graph as well. Okay, so we know our information now to solve the binomial model. We have the current prices today of all the assets. We have the payoffs of all the assets. We have the rates of return on the stock. We have the risk-free interest rate. We should be good to go in terms of pricing and forming the replicating portfolio. So that's exactly what we want to do in parts 2 and 3. In part 2, we want to solve for the replicating portfolio. What does this mean? It means we want to calculate the delta and the beta of the put option, where delta tells us the number of shares we need to own, and beta tells us the number of bonds we need to own. We can do this in one of two ways. Okay, the first way that I'll highlight to you is just the plug and chug method. So we'll write it down, plug and chug. This is if you just want to memorize the formulas. Okay, so if you just memorize the formulas, you'll remember that delta is the change in the put price, PU minus PD, over the change in the stock price, S0 U minus D. If we just plug and chug, what are we going to get? Payoff to the put in the upstate is what? It's 0. It's 1/2 in the downstate. Stock price originally is 1. U is 2. D is 1/2. Okay, simplify this out. You're going to have 1/2 over 3/2. What is this going to equal? It's going to equal negative 1/3. So the replicating portfolio is going to own negative 1/3 shares, or you're going to short 1/3 of the share of Red Rock Resorts. How many bonds are you going to own? Again, if we want to do the plug and chug method, we just write down the formula. PD.U minus PU.D over U minus D. Plug and chug. Payoff of the put in the downstate is 1/2. Gross rate of return in the upstate is 2. Payoff to the put is 0 in the upstate times the gross rate of return in the D, 1/2, over U minus D, 2 minus 1/2. This is going to be equal to 1 over 3/2, which is going to be equal to 2/3. So therefore, the replicating portfolio is as follows. Rep port is short 1/3 shares, delta equal to negative 1/3, and long 2/3 bonds. Okay, beta equal to 2/3. Okay, if you own this portfolio, then it's going to match the payoffs of the put in every state of the world by construction. Okay, so that's the plug and chug method for finding the replicating portfolio. The other method you could use is the system of equations method. Okay, and this one is where we don't want to memorize any formulas. We just want to use the underlying principles of pricing by replication and then back out delta and beta from this. Okay, so what you need to do for the system of equations approach is write down your two equations and two unknowns. Okay, we start with the first equation. It equates the payoff of the put in the upstate, PU, equal to delta times SU plus beta times 1. And the second equation equates the payoffs in the downstate, PD equals delta times SD plus beta times 1. Okay, let's plug in some numbers. PU is 0 equals to delta, which is what we're going to want to solve for, times SU. What was this? This was 2 plus beta times 1. Okay, we want to solve for beta as well. Payoff to the put in the downstate now, second equation, 1/2 equals delta times SD, 1/2 plus beta times 1. Okay, call the first one equation 1, call the second one equation 2. Let's subtract equation 1 from equation 2. Okay, what is this going to imply? It's going to imply that 1/2 minus 0 is equal to delta times 2 minus 1/2 plus beta times 1 minus 1. Simplify this, 1/2 equals delta times 3, excuse me, this is the negative right here, okay, 1/2 minus 2. This is equal delta times negative 3/2. This implies that delta equals to negative 1/3, just like we solved for above, right? So above we had that delta was equal to negative 1/3 using the equations, the equation. Now if we solve the system of equations, we get the same exact result. Okay, now what we can do also to find the beta is we just plug in the values to either of the equations. We just plug in the value of delta into either of the equations. Let's plug in delta to equation 1. So plug in delta to 1. Okay, so equation 1, once we plug in delta, is going to become one equation, one unknown. It's going to be 0 equals delta negative 1/3 times 2 plus beta times 1. This is going to imply that beta is equal to, move this over to the left, equal to 2/3. Okay, which is the exact same as we had before. Okay, either way is going to yield you the correct results. Good way to check your answer on a test, do them both. Okay, finally, what we want to do in part 3 is we want to calculate the payoff, or the price of the put option. The put price, we can do this in either way. So first way we can do it is just plug and chug. Okay, this is where we just remember the formula. The put price is given by P sub 0. This is equal to the formula. It's going to be equal to P sub U minus P sub D over S0 U minus D times S0 plus PD dot U minus PU dot D over U minus D times e to the negative RT. Plug in a bunch of inputs. What are you going to get? PU is 0, PD is minus 1/2, S0 is 1, U is 2 minus 1/2, S0 is 1. Finally, plug in the inputs. I won't read them out. I'll just write them down. Half times 2 minus 0 times 1/2, 2 minus 1/2. Price of the bond is 1. Okay. You work through this, you calculate it all out, and what you're going to figure out is that the price of the put option, no arbitrage price, is going to be equal to 1/3. Okay. Alternatively, what you can use is the replicating portfolio price method. This is where you don't remember this whole equation out, what you just do is you go out, you calculate delta and beta, and then you calculate the cost of owning delta shares and beta bonds at date 0. So P0, we always know has to equal delta times S0 plus beta times 1 by construction. We've calculated delta and beta in the last slide. Delta is equal to negative 1/3. This is personally my preferred method for doing this, times the stock price of S0 is 1, plus beta, which is going to be 2/3, times 1. Add this up, it's minus 1/3 plus 2/3, it's equal to 1/3. So the put price is equal to P0 equal to 1/3. Okay. Easy, right? No problem at all. Just wrote down some payoffs. We calculate some replicating portfolios. And now what we're doing is we're calculating the put price in the final step. Okay, so one more practice problem, and that'll wrap up this lecture, okay, or this part of the lecture. Give you a minute to read it, then we'll work through it. Okay, so problem statement is as follows. We're still in a binomial world. Two dates, 0 and 1. Okay, date 0 is today. We know what it is. Date 1 is the future. 1 year from now, it's the unknown. Two possible states at date 1, the upstate and the downstate. We're interested in Peloton stock, another hot stock during the coronavirus. It's trading at $20 per share. Peloton does not pay dividends. At date 1, we're given the prices of Peloton stock, but we're given it in terms of the gross returns. The gross return will either be U equals 1.5 in the upstate or D equals 1/2 in the downstate. The continuously compounded risk-free interest rate is going to be 1%. There's no arbitrage, and we want to price a European put option on Peloton with a strike of 20 and a maturity of 1 year. We want to price this put option, and then we want to go out and we want to price a call option as well. And the way we're going to do that is we're going to use put call parity, just like we did last lecture. Okay, let's start by writing down our inputs. We'll draw our binomial tree. Good practice. Two dates, 0 and capital T. Today's date at date 0 is the known. Date T in the future is the unknown. Okay, 1 year from now. There are three assets, the stock, the bond, and the put option. Okay, the stock has a price of S0 equal to 20. The stock has a payoff in the upstate of SU equals to U dot S0. We're given U, it's equal to 1.5 times the original price, so the payoff in the upstate is 30. The payoff to the stock in the downstate is given by S sub D. It's equal to D times S0. We're given both. It's equal to 1/2 times 20, which is equal to 10. Okay. The second asset is the bond. The bond has a price of B0 equal to E to the negative RT. Here the interest rate is not 0, it's 1%. Okay, we have 1 year of maturity. This is approximately equal to 0.99 price of a bond. Discount bond, paying 1 at date 0, date 1. Payoff to the bond is always 1, BU equals 1, BD equals 1. This is again because it is a risk-free bond. Okay, what we want to do is we want to calculate the no arbitrage put price, and actually later we're going to actually want to calculate a call price as well. Okay, to calculate the no arbitrage put price, we're going to need the put payoffs. Okay, in the upstate, the payoff of the put is going to depend on the payoff of the stock. Okay, the strike of the put is given by 20. The put's payoff in the upstate, PU, is equal to the maximum of the strike price in either state minus the stock price in the upstate. Strike price is 20. Stock price in the upstate is 30. So the put payoff is the maximum of negative 10 and 0, which is just 0. In the downstate, put payoff is given similarly. It's the max of the strike and the stock price. Strike minus stock price and 0. Okay, plugging in our input, strike is 20. Stock price in the downstate is 10 and 0. Maximum of 10 and 0 is obviously 10, so it's 10. Put payoffs are PU equals 0 in the upstate. PD equals 10 in the downstate. Stocks payoffs are 10 in the downstate, 30 in the upstate. Bond always pays off equal to 1. Okay. Now what we want to do is we want to answer these two questions. First, what is the price of the put option? And second, what is the price of an otherwise identical call option? Okay, we know by now that there are multiple ways we can go out and calculate the price of the put option. Instead of going through, calculating the replicating portfolio again, it might just be easiest to go out and plug in the values from the baseline plug and chug equation. So we're going to use the plug and chug method here to calculate the no arbitrage put price. Should be very familiar to us after this last practice problem we did. Okay, so the put price is given as follows. It's equal to the delta, which is PU minus PD over S0, U minus D, multiplied by the stock price today, S0, plus the beta, which is PD dot U minus PU dot D, over U minus D, okay, times the discount bond price, e to the negative RT. Okay, let's start plugging in some inputs. PU, payoff in the upstate, is 0. Put has a positive payoff in the downstate, though. It's 10. Stock price today is 20. U is 3/2. D is 1/2, 1.5 versus 1/2. Stock price today is 20 again. The beta is given as follows. PD is 10. U is 3/2 minus PU, which is 0, times D, 1/2 over U minus D, 3/2 minus 1/2 times 0.99. Okay, let's cancel out some like terms here. Okay, 20 and 20. Okay, this is going to be 1. This is going to be 1 as well. Okay, so we're going to have equal to minus 10. Okay, plus 10 times 3/2 times 0.99. What you're going to arrive at is that this is going to equal 4.85. Okay, thus the no arbitrage put price by the plug and chug method is P0 equals to $4.85. Okay. This was just via the plug and chug method. We could have also done this in a different way. We could have went out, calculated delta and beta, and then used the price of the replicating portfolio. We would have gotten the same result. It's probably easiest to just plug and chug here in the interest of time. Okay. In part 2 of the question, what we do is we want to price an otherwise identical call option. This is a call option with a strike of K equals to 20 and a maturity of T equals 1 year, still on Peloton stock. We could do the whole calculation from the last lecture. We could go out, we calculate CU, we calculate CD, and we could plug everything into this formula that we learned here. However, it might just be easier to use put-call parity to find our result. Put-call parity tells us that the price of a fiduciary call equals a protective put, or that is the protective put, P0 plus S0, The price of this has to equal the price of the fiduciary call, C0 plus K e to the negative RT. Okay, what we can do is we can rearrange this formula to solve for the call price, just like we learned in lecture 10, I believe, or lecture 9 maybe. It's that C0 is equal to P0 plus S0 minus K e to the negative RT. We know the put price, we know the stock price, we know the strike, and we know the discount factor. Let's just plug in inputs. Put price, $4.85. Stock price, 20. Strike price, 20. Discount rate, e to the negative 0.01 times 1. Plug all this in, calculators out, you're going to get something around 5.05. Okay, so the no arbitrage call price on a call on Peloton with a strike of K equals 20 and a maturity of 1 is C0 equals to $5.05. Okay, put call parity, super powerful once we have 3 of the 4 unknowns, or there's actually 4 of the 5 or 6 unknowns. Okay, all right, so that wraps up the third part of lecture 11. Let's take a quick break and we'll resume the lecture in the next video.